Today we're going to analyze the trigonometric functions f over the specific interval, stating whether f is increasing, decreasing, concave up, concave down, and stating the x-coordinate of an inflection point. So we're given f of x equals sine x minus cosine x. So to find the intervals where it's increasing, decreasing, you take the second derivative. So f prime of x. Okay, so the derivative of sine x is cosine x, and then minus a negative sine x. So you're left with cosine x equal plus sine x. Good. Now the second step is to set that to 0. Cosine x equals sine x equals 0. Now what you can do is you can subtract sine x, or you could just leave it like that. You got to figure out what are the radians that'll give you when added the cosine x and sine x will give you 0. So I'll just leave it like that. And the intervals are from negative pi to pi. So first we gotta graph our trig line. So we have from negative pi to pi. So I will use 3 pi halves, right? Because 3 pi halves we have a negative root 2 over 2 comma root 2 over 2. So when that added gives you 2, gives you 0. So that works. What else can we use? We can use negative pi, or you can also, it's the same thing as 7 pi over 4, right? Negative pi over 4 is the same thing as 7 pi over 4. And the coordinates are positive root 2 over 2, comma negative root 2 over 2. So when you add those, that gives you 0, so we can use that one. So the next step is put it in a number line. So our boundaries is from negative pi, so that's our lowest. So we're going to put negative pi, and then we're going to use negative pi fourth, right? And then we're going to use 3 pi fourths, and then pi, right? Because that's our highest point. Now, since we have boundaries, we don't have to figure out what's on the right side of pi or the left side of negative pi. We just need these points, like these. We need to know if it's positive here, here, and here. We don't have to care about if it's positive to the right side or the left side because of the boundaries. So I need a number between 3 pi and pi, right? So I will use 5 pi over 6, because 5 pi over 6 is between here. So yeah, you really need to know your trig for this part. So 5 pi over 6 is negative root 3 over 2 plus 1/2. And that gives you a negative, so you put a negative. And then I need a number between negative pi fourth and 3 pi fourths. And I will use 2 pi. Because here's 2 pi, right? So I get negative 1 plus 0, which is, it's positive 1 plus 0, sorry. So that's positive. So you put positive sign. Now I need to know a number between negative pi and negative pi fourths. So here's negative pi and negative pi fourths. I can use 3 pi halves. Positive 3 pi halves. Or you can also use, instead of positive 3 pi half, it's also negative negative pi, right? Because they're the same thing. As get negative. So where it's increasing is from negative pi to negative pi fourths, and then union 3 pi fourths to pi, right? Negative pi, 3 pi fourths. Sorry, I mean that was decreasing. Increasing is from negative pi fourths to 3 pi fourths. So wherever there's a positive, that's where it's increasing. And decreasing is from negative pi to negative pi fourths, union 3 pi fourths to pi. And we have a local min. So remember, when you have a min, you have to have a negative sign and a positive sign. So our local min is negative pi fourths at x equals negative pi fourths. And our local max is at x equals 3 pi fourths because we have a positive and negative sign. And if you wanted to find the y coordinate, you just plug in negative pi. You plug in 3 pi fourths into the original function of f of x, not the f prime of x. So if you did the work, you should get positive root 2. And then for the min, you should get a y value of negative root 2. Okay, so we found our increasing, decreasing, and our local min and local max. Now we got to find concave up, concave down, and then our inflection points. So in order to do that, you got to take the second derivative. So let me erase some of these. Oops, yeah. Sorry. You know, it's just let me erase. Just let me blank. I'm just gonna clear all. Okay, so we got to find the second derivative, right? So we got to find the concave up, concave down, and then inflection point. So you got, in order to do that, all you got to do is take the second derivative. So f prime, f double prime, second derivative. So that's negative sine x plus cosine x. Okay, and then you set that to 0. This part, I'm actually gonna add sine x to the left side. I mean, on the right side. So we have cosine x equals sine x. So we need to know a degree in radians that'll give you will give you the same value of a cosine will give you the same value of sine x. So let me graph my coordinates. And we're still from the intervals of negative pi to pi. So I will use pi fourths because positive pi fourths because it gives you the coordinate of root 2 over 2 comma root 2 over 2. I mean, is it true? So the cosine is root 2 over 2, and the sine is, so that's true because root 2 over 2 equals root 2 over 2. Where else can we use it? Can we use, can't, so we can use negative 3 pi fourths. It's also the same thing as positive 5 pi over 4. The reason why I'm saying negative 3 pi over 4, because our boundaries is from negative, so that's why it's a negative. But negative 3 pi fourth and is the same thing as positive 5 pi over 4, and then they give you the coordinate of negative root 2 comma negative root 2 over 2. So next step is graph the number line. And so our boundary is from negative pi, right? So here's negative pi. Negative 3 pi fourths. Our next one is negative 3 pi fourths. And then our next one is positive pi over 4. And then our next one is pi. Okay, so we don't need to know on the right side of this because we have boundaries from negative infinity to positive infinity. So we just need this boundaries, this one, and this one. So I need a number from pi fourth to pi. So I will use, somewhere between, here's pi fourth and pi. Pi is right here. So I could use pi halves, right? And then the coordinate of pi half is 0, 1. So f double prime of pi halves is negative 1 plus 0, right? You know how I got that? Because coordinates is we're putting it in this equation. Because coordinates is 0, 1, so negative sign is negative 1, and then plus 0. Anyways, it's negative 1, so it's negative. So we gotta put negative right here. Okay, now we need a number between negative 3 pi and pi fourth. So negative 3 pi 4 and pi fourth is right here. So we could use 3 pi halves. So we need a number between negative 3 pi fourth and pi fourths. So yeah, that's how I got 3 pi halves. So 3 pi halves. Coordinates of 3 pi halves is 0, negative 1. So it's going to be negative 1, negative 1 plus 0, which is positive. This becomes positive, so it's just 1. So this is positive right here. And then we need to know a number between negative pi and negative 3 pi, and I'm going to use 7 pi over 6, right? So where are we? So we need, here's negative pi, and then negative 3 pi negative 3 pi fourth. So I'm going to use positive 7 pi 6. So that's negative 1/2 plus negative root 3 over 2. This becomes positive, anyway, it's still a negative number, so we're going to use. Okay, so now we know concave up is from, so wherever it's positive, so it's from negative 3 pi over 4 to pi fourth. Concave down, wherever you see a negative number, so it's from negative pi to negative 3 pi fourths. Union pi fourths to pi. So concave up is from negative 3 pi fourth to pi fourth, and concave down is negative pi to negative 3 pi fourth, union pi fourth to pi fourth to pi. Okay, so yeah, this part you actually need to know the trig really well. So, and then our inflection point of x value at x equals, it's basically negative 3 pi fourth and pi fourths. Pi fourth and then pi fourth. Okay, so if you wanted to really understand this, you would have to graph it again. You would have to graph the original function, so I'm going to erase everything. So if you were to graph it, oh my god, this is horrible. So if you were to graph the function f of x equals sine x minus cosine x, it would look roughly something like this. So So, this is one coordinate, the y-intercept, and then this one right here is pi fourth, comma 0. And then this point is about, here's 1, 2. This point is 3 pi fourth, comma 1.44. So it's going to look something like this on the right side. So on the left, this is one. On the left side, so it would be right here. This is negative pi fourth You could just put this in a graphing calculator if you want to. And then this point is -3 pi 4th comma 0. So it would look something like, oops, sorry. So yeah, you can make it look so much nicer if you put it in graphing calculator. So that's how you do it. That's how you do the trig, and that's it.